Greetings to every one of you. In this video, we are going to discuss another important concept from data structures and algorithm, that is bubble sort. Bubble sort, which is a very common procedure, a basic method of sorting any given number of values. Let us see how this algorithm works. The sorting procedure, bubble sort, which contain the array of numbers and where n represents the number of elements. So repeat the step number 2 and 3 for I is equal to 1 to n number of times. And step 2, repeat step 3 for j is equal to 1 to n number of times. And step number 3, we are going to check a condition that if a of j is greater than a of j plus 1, then we have to perform a interchange of this a of j with a of j plus 1. It is temporary variable, temp is equal to a of j, and a of j is equal to a of j plus 1, and a of j plus 1 is equal to the temporary variable. Step number 4, it is nothing but end. So every time you are comparing a value with the consecutive value, the next value, if this value a of j, it is greater than the next value, that is a of j plus 1, perform the swapping. Swap is nothing but interchanging the position of the elements. The value of a of ij will stored in the place of a of j, and a of j will be stored in the place of a of j plus 1. This is what is called swapping. It is nothing but interchanging. That is what we have to do if the condition is true. So this procedure we have to do it for what is that, n number of times, and we are doing this loop for I is equal to again 1 to n. Consider this example. We have 5 different values. Array contain 5 values. Now we are going to perform this sorting on this array. Let us consider our value, that is 9, 6, 8, 4, 3. These are the values of the given array. What you have to do, you have to compare these two elements. Let us consider this is a of j and this is a of j plus 1. A of j is greater than a of j plus 1. What you have to do? We have to swap the elements. Okay, so that means 6 will go there and 9 will come here. So the remaining elements are as it is. This is the first check. The second check, you have to again compare it with the next element. So this is 6 and here this is a of j and this is a of j plus 1. Now a of j is greater than a of j plus 1. Again perform the swap. This is 4 and 3. Now we have to check for the third position, third element. Now again this is a of j and this is a of j of plus 1. Okay, so condition is true. Again we have to perform the swapping operation. Now at last again check it. A of j, this is a of j plus 1. So again the condition is true. You have to perform the swapping. So 6, 8, 4 and this is 3 and this is 9. And this is what is called one pass. So this is the first pass. What actually I have done, I have taken the first element and just we compared with the consecutive elements. So in this case, how many number of comparisons and how many number of swapping we performed? We performed 4 comparisons and 4 swaps, isn't it? Right? Now take this result. The result is 6, 8, 4, 3, 9. Again, you have to repeat the same procedure. Take this value, compare it with the next one. Okay. So, this is a of j and this is a of j plus 1. So, a of j, it is not greater than a of j plus 1. So, here no swapping. So, just it will be as it is. Okay. Now, you have to compare with the next element. Okay. So, now this 8, it is greater than 4. So, swapping, we have to perform swapping. So, 8 will go down and this is 3 and 9. Again, next comparison. Okay, 8, this is a of j and this is j plus 1. Now, again, a of j is greater than a of j plus 1. We have to swap the elements. This is 6, 4, 3, 8, this is 9. So, no more swapping is required because already the last element, which is the maximum element. So, in this case, actually this element, the first pass, the 9, the first value, it is sorted. One element is sorted here, that is one element is sorted. But now, in this case, see that 2 elements sorted. 2 elements sorted. How many comparisons we have done? Actually, we have performed 3 comparisons. As far as swap is concerned, we have performed only 2 swaps because here we have not done the swap. So that we can take it for account. Suppose if the value is bigger, definitely we would have performed 3 comparisons, 3 swapping. Okay. So make a note that we have performed 3 comparisons and there is a chance for 3 swapping. But in this case, we have performed only 2 swap. The maximum number of swapping is possible. It is 3. Okay. Now take this output. This is 6, 4, 3, 8, 9. Again, perform the comparison. So 6, it is greater than 4. Condition is true. We have to perform the swapping. Remaining values as it is. Now this is a of j and this is j plus 1. Again do the comparison. Again 6 is greater than 3. So the 3 will go here and 6 will come here. 8, 9. So now we can find that the last 3 elements are sorted. Okay. So 3 elements are sorted here. Okay. Take this output. The third pass is over. 4, 3, 6, 8, 9. Now perform the comparisons. So as far comparison is concerned, here you have performed only 2 comparisons and 2 swaps. Okay. So here compare this. A of j is 4. A of j plus 1 is 3. Okay. Condition is true. So we have to perform swapping. So this is 3, this is 4, 6, 8, 9. Now we can see that the result is very well sorted. The elements are very well sorted. So here we have performed only 1 comparison and only 1 swap. So all the 5 elements are sorted with 4 passes. So if you have 5 elements, we need to perform this 4 passes. So that means if you have n number of elements and you need to perform n minus 1 number of passing. So as for how to calculate what is the amount of time taken for performing this sorting, you compare all these 4 passes. So in the first pass we had 4 comparisons, 4 swaps. Here the second one we got 3 comparisons, and of course maximum possibility of swapping, it is 3 swapping, but we have done only 2. But in this case we can consider maximum possibility, that is 3 swapping are possible. Similarly in the case there is 2. Similarly here it is 1. So what is that? It is nothing but, the time is nothing but the number of comparisons. It is equal to 1 plus 2 plus 3 plus 4, etc. Similarly the number of swapping, it is 1 plus 2 plus 3 plus 4. If it is for n number, this is for 5 numbers, we got this value. Suppose if it is for n, it is nothing but that is up to, that is n minus 1. This is n minus 1, right? So it is nothing but it is n into n minus 1 divided by 2. N into n minus 1 divided by 2. So what is this? This is n square. It's nothing but sum of the natural numbers. Okay, n square minus n by 2. So the order, the time complexity for this bubble sort is nothing but order of n square. Make a note of this. So this can be asked as a question. What is the time complexity of bubble sort? And another interesting the thing about bubble sort I want to tell you, it is why actually we call this sorting method as bubble sort. See, in a water surface, if you drop a stone, what will happen? The stone, it has its own mass, weight. Because of its weight, it goes down. But the lighter particles like the air bubbles are coming up, the heavier one is going down. That is how actually it is happening. See this value number 9, slowly the number 9 is what's that? It is coming down, but the lighter values, lesser values are going up. See that? The lesser values are going up, but values with what's that? More weight, it is coming down. Because of this, one particular reason, it is named so. Bubble sort. And of course, it is an interesting fact. I hope you understood the concept of the bubble sorting, how actually we can perform. Just I gave this algorithm, and also with the example I explained how to perform this the passing, and finally just I have shown you how to derive this time complexity. Thank you. Keep watching.